Hello everyone. Today we're going to be looking over the Force Basics worksheet. So this is if you had any trouble getting any of the questions. You can of course feel free to skip around in this video to find the questions that you may have had trouble with. Now there really are two big questions in this worksheet that are kind of the overarching what you can expect from a force like style question, and that is 1 and 4. 1 and 4 all have the same basic goals, where you first need to figure out the net force based on the forces that were given to you, and then using that net force figure out how that affects the motion of the object. In this case, your goal is to find the acceleration. So for each of these, I would highly recommend actually drawing one of those free body diagrams. That's why we practice them. There's never a time where you're like forced to draw them for an assignment. They're just merely there to help you out. So to start with, we have a object that's on a level floor, which means we have some gravity going up and we have our normal force going down. However, those really don't matter too much, and they're not even specified in the question because they just cancel each other out. The actual interesting thing is that we have this force going to the right, which we know is 70, and we have a frictional force that's also on this. Now, it doesn't say which direction the friction force is, but you should know that friction always fights against the motion, so it's going to be that way, and it's 10 newtons. So the up and down cancel each other out. We have the 70 to the right, the 10 to the left. They add up to equal a net force of 60 newtons. Now to finish this question off, we're using our acceleration formula, F net over m, where our F net is 60 newtons and our m is, 20 kilograms? 20 kilograms. So you just need to divide the two, and when you do that, you get 3 meters per second squared. Now this is the style question, the more complicated one for sure than the rest of these on the worksheet, but the one that I want you to get used to doing the most. We might not have this sheet totally down yet. Don't worry, we're going to be practicing much more. But this is the type of question I want you to focus on. All right. Question 2 has a object weighing 2 newtons. So weight is Fg. It's pushed across a horizontal frictionless surface. So it's frictionless, so we know there's no friction on it. By a horizontal force of 4 newtons. Now, it doesn't specify which direction, but I don't think it matters in this question. So I'm going to say 4 newtons. What is the magnitude of the net force? Now, your first instinct may be to add these up together, but you can see that's not even a choice here, so that doesn't work. Your next instinct may be to do a squared plus b squared equals c squared, but again, that's not a choice here. And the reason why is because there's one more force on here, and that's a force going up by the normal force. And I know that these forces are equal to each other because we're on a surface. So the fact that we're on a surface means that these two are canceling each other out. The fact that it's a horizontal surface means they're opposing each other, which means really the one force and the only force that matters here is our... Sorry, my cat's wanting to check out the window. Sorry if this makes it too bright. Okay, so the one force that matters is that 4 newtons, and that is actually our answer right there. Next question should be really easy. We just cross out the word inertia and replace it with the word mass, and right away it should be a very easy question. What one has the greatest mass? That's that right there, which means choice D. Those should be very straightforward. Okay, question 4, like question 1, we have our multiple forces on our box. We have gravity and normal force. They almost always cancel each other out. We're going to see one example where it doesn't later on in this worksheet. We have our force going to the east of 27, our force going to the west of 17. They're going to add up together to be 10, because again, they're going opposite directions, you subtract. And then all you have to do to find the acceleration, is to divide it. Apparently it doesn't want me to draw anymore. To figure it out. There it goes. I don't know what happened. Divided by our 5 kilograms. And when we do that, we get, of course, 2 meters per second squared, which is our answer over there. Okay, 5 is another mass question. Mass is always the same no matter where you are. However, the weight changes based on gravity. The moon has less gravity than Earth. That's why they're all bouncy, if you've seen any videos of them on the moon. So the mass would be the same, but the weight would be less on the moon. That looks like choice 2. Okay, question 6. Looks like it's a complicated question, but the important thing to get off of this, a lot of people are going to treat this as an acceleration and want to plug it into our formula. A is equal to F net over m. But that value is not an acceleration. That value is a speed. In fact, it's a constant speed. And you should know, anytime you see constant speed, that means we're at equilibrium. My forces cancel each other out. So with the forces canceling each other out, we have no net force over here. So it's choice 1. So it seems like it's a tough question or a question that we have to do math, but once you see constant speed in a force question, you should know the force is 0. Next one's asking for which one could be at equilibrium. Again, that's the forces cancel out. Well, it can't be that one. Forces definitely aren't canceling out. Can't be this one. Bottom is winning. The two left and right forces cancel each other out for this one, which is good, but that one does not work because we have the force going down. This is the only one that could work out for us, and let's see it. So the rightness of this one cancels out with the leftness of that one, and then the upness of this arrow plus the upness of that arrow cancels out this arrow over here. So because everything's canceling out, it is choice 4. Okay, here's our elevator question. Now we're going to do much more practice when it comes to elevators later on, but let's take a peek at what that means. So for the elevator question, we have a force that's going down, and that's gravity. And we know what that force is. It's 750 newtons because that's the weight of the object. Now, when you're on an elevator, you have the normal force holding you up because you're standing on the ground. But because you're accelerating, you can actually have a normal force that's greater if you're accelerating upwards or less if you're accelerating downwards, which you are in this case. So because you're accelerating downwards, our upwards force needs to be less. So this wins and you end up accelerating down. So our final answer for this is choice 2. All right, that's everything I have on this worksheet. If you struggled with it, don't worry too much. This is our first look at forces. We're going to do plenty of more practice as time goes on. I hope you guys have a good day, and I will see you next time.